Okay, chapter 5.4, problem number 7. The problem says this: some proposed flights to Mars are inexpensive ventures because all unmanned space missions are inexpensive ventures, and some proposed flights to Mars are not manned space missions. Okay, so the very first thing I want to do here is to start to make this problem a little bit more manageable. Okay, and it's most manageable the more I can simplify it. So the first thing I want to do is see if I can find the conclusion. If I can find the conclusion, then I'll be able to figure out what the order of the premises are in order to get the argument into standard form. Because I know that the predicate term of the conclusion is the major term, and it's going to appear also in the very first premise, and the subject term of the conclusion, the minor term, is also going to appear in the second premise. So if I can identify the conclusion first, it just makes it easier for me to start organizing and arranging ideas. So I'd want to start looking for any indicator words like for a conclusion, therefore, thus, consequently, hence. And for premise indicators, words like because or since. And you can see here that I do have the word because right here in the statement, but I also have the word and, okay? So I know that because is a very typical premise indicator. What follows it is likely to be a reason in support of a conclusion. But I also see the word and is telling me that the two sentences that appear on both sides of it are kind of doing the same thing. This is true and that's true. Not this is true because that's true, but this is true and that's true. So again, when I put all this together, I realized that, well, if because is a premise indicator, then what follows it is one of the premises, but also what comes before because is the conclusion, because it's the statement that somebody is telling me is true and then saying it's true because of this other statement. So what I want to do now is I want to get this written out into a more manageable form. And for me, that means taking this one big long sentence that's made up of three separate sentences and putting it into three individual sentences. And it's best if I can organize it so that the conclusion appears last and that the major term of the argument, which is inexpensive ventures, also appears in that first premise. And the minor term of the argument, proposed flights to Mars, appears in the second premise. Now, you'll note that we've got our three terms, and they don't appear exactly the same way the two times they appear. So inexpensive ventures appears the same way both times, and proposed flights to Mars appears the same way both times. But I've got manned space missions and unmanned space missions. But what's important to recognize there is that those are term complements of one another. So one is really, an unmanned space mission is really a non-manned space mission. Okay, so it'd be fine to write it as unmanned or non-manned, either way you like it. But what's important about this is recognizing that unmanned and manned space mission are really related to one another. I can identify three terms that I can then use to represent this argument symbolically. And once I start representing it symbolically, it starts to get easier and easier and easier to work with. So if I take this argument and I use M, E, and P, and I translate that first premise, all unmanned space missions are inexpensive ventures, I would translate that as all non-M are non-E. And then the second premise would just be some P are not M. And then the conclusion would be some P are non-E. Okay, so now I've got my argument boiled down to a pretty manageable form. It's certainly much more manageable than it was originally. But I notice that I don't have my terms appearing the same way each time. I've got M and non-M. And so I want to eliminate as many of the nons as I can. It's always best to eliminate the nons, okay? So I'm just going to start with the very first premise. And when I look at that, I'm thinking to myself, well, are there any rules that I could use alone or in combination that would allow me to get rid of those two nons, okay? Because the subject and the predicate are both term complements of M and E. And I recognize that contraposition is that rule that allows me to flip the position of the subject and predicate and replace them then with their term complements, okay? And so the term complement of non-M would be M, and the term complement of non-E would be E. So I'm going to go ahead and contrapose that very first premise. And when I do, I get rid of two of the nons. I have all E or M. And then I don't have to do anything to the second premise because there were no nons in it. But I do need to figure out a way to get rid of that non in the conclusion. And one of the things that I remember, because I remind myself, is that when I see only one of the terms having a term complement, I know that I'm probably going to be using obversion. Okay, sometimes I might have to convert before I obvert, but I know that I'm probably going to be obverting. Okay, and remember what obversion is this: it's two steps. You change the quality but not the quantity. Okay, that's the first step. And all that means is if the statement is affirmative, like some P or non-E is, we'd have to make it negative, which would mean it would turn into some P are not non-E. And then the second step of aversion is I replace the predicate with its term complement. And I wind up with some P are not E. So now I've got this argument in rock star standard form. And I got my three terms. They're appearing the same way each time they appear. And I can start to apply the rules. The first rule says this. The middle term has got to be distributed at least one time, and the middle term is M. Okay, that's the term that appears in both the premises but not the conclusion. And I know that that second premise is an O claim, and O claims distribute their predicates. So M is distributed, the middle term is distributed, so it passes rule number one. The second rule doesn't apply here, because the second rule says if there's something distributed in the conclusion, it would also have to be distributed in a premise, but there's nothing distributed in the conclusion. And the third rule seems to be satisfied. I do not have two negative premises. I'm not allowed to have two negative premises, and I don't. But the fourth rule says if you have a negative premise, you have to have a negative conclusion, and if you have a negative conclusion, you have to have a negative premise, and I do. And the fifth rule doesn't apply here, and it doesn't apply because I don't have two universal premises in a particular conclusion. I actually have a particular premise and a particular conclusion. So according to my application of the five rules, this is a valid argument. Now what I could do, if I wanted to really go above and beyond. Oh my God, that's a terrible circle. Wow, okay, we're starting that one over. Is I could do a Venn diagram, okay? I'll number my little spaces here. And I've got my P and my M and my E. Now remember, I always have to begin with a universal premise, always. And so I'm going to have to begin with the very first premise here that all E are M. So if all the E's are M, that means there couldn't possibly be any E's over here in 6 or in 7. Because if there were any E's there, those would be E's that weren't M, and then the statement all E are M wouldn't be true. But I want to show that the statement all E are M is true, so I have to shade in 6 and 7. And then what I have to do is I move on to the second premise, okay? And it's a some or not statement, which means I'm going to be putting an X somewhere. And in order to show that some P are not M's, there's only one place I could put it. If I put it in 2, that would be a P that is an M. And if I put it in 3, that would be a P that's an M. And I'm trying to show that some P are not M. So the only place there could be an X is right here. Some P are not M. There's a P that's not an M. And so now I set my pen down, and to determine whether or not this is valid, I look to see if I see the conclusion represented here in this Venn diagram, that some P's are not E's. And I do. So now I've proved it valid two ways.